Hello, this section is entitled Logging, Monitoring, Manage Application Logs. So the first thing we want to do is remind ourselves how basic logging works with Kubernetes. And the way it works for applications is that each container can write to standard out and standard error. Those are essentially Linux or Unix concepts, right? And those are just basically file descriptors that can be written to. And those are being collected by the container engine, in this case Docker. And Kubernetes relies on that, right? And one other thing that Kubernetes does as a container, you're inside a pod and the container might restart, right? And instead of losing all that data, all the standard error, it keeps basically the last terminated container around with its logs, keeps it around, right? And that way you can look at maybe the last time the container crashed, right? And that way you're not losing that data. And then lastly, though, if a pod goes away from the node, all that corresponding data is lost, right? So these are the logs. This basic logging is fairly transitory. It only exists essentially as long as the pod lives, and there's limited lifetime of the container. The logs for the container. Basically, the last container that was running can be seen also. Okay, so to show this, we're just going to run real quick. We're just going to run a container here. So let me look at the container real quick. The pod. We're going to run a pod with a container in it. That is. Ooh, make this bigger. Logger. Templates. Example. So it's basically a pod running Ubuntu, right? And it's just running a loop here, basically dumping out the name of the machine, the date, and an iterator, waits a second, and just repeats again, right? So this is just going to spit out, and there's the echo here is writing, in this case, to standard out, right? So this should show something in the log. Okay, so let's run this. Helm install dev logger. Okay, so let's look to see it's running. It's running. So the command is, make this bigger too. Okay, so we're going to do kubectl logs example dev. Okay, so you can already see it's spewing out the logs here, right? You can also do, I believe it's -f for follow, and you can see that it's, as the log keeps on adding, it just keeps on updating itself. Okay, so that's an example of how to get sort of the most basic way of getting at logs. Again, these are fairly transitory, and once your pod expires, they go away. Okay, so real quick, we're going to do a quick sidebar, and this was just because I started seeing some examples, and I found myself getting confused between Docker terms and Kubernetes terms. So as a quick reminder, when you build a container in Docker, there's two having to do with the execution, what command you're running. There are two keywords. One is called entry point, one is called command. And they work together to determine what actually gets executed in your container. So in the world of Docker, entry point is pretty much what it is, the entry point. It starts with an executable and a parameter, as many parameters as you want. You can actually have arbitrary number of parameters. And the idea here is, but it always starts with executable for sure, and it tells you what command inside the container, what file that you're going to actually execute in the container, and then parameters are parameters to that executable, right? Now, if you supply a command also, It can come in two forms. One, it could be an executable and two parameters. And that's kind of essentially, I've never really used that case. That case would be essentially if you didn't have an entry point, right? The more common pattern is you provide an entry point with an executable, maybe a couple default parameters, and then command is more parameters get tacked on the end of entry point. So the purpose of the separation is one can be, entry could be, you can imagine being more fixed. The developer of the container may set the entry point, and then they encourage the user to then just change parameters about the command. So either way, that's how Docker works. Now, this essentially works the same for, so every container has that, and on top of that, when you build your pod and you're working with a container, you actually supply two different things. Unfortunately, the names somewhat conflict. So one is called, so there's a command, and command in your mind here should be synonymous to the entry point, or args here should be synonymous to the command. So they kind of, so again, the word command here is kind of used two different ways. Here's command and here's command. But it should be command is the same thing as entry point, and arg is the same thing as command in Docker land. And so the pattern is, I'll just read through them real quick. If you don't supply either of these, then the Docker container will basically run off of its own entry point and commands, however it's configured. If you supply a command, right, but no args, then the only thing that runs is your command. I mean, if you supply your command, which overrides the entry point, it's going to run with that, right? But it's not going to use the command, anything from the command in the container, right? And then if you only supply args, which is essentially the second entry here, like this pattern, if you supply args, then it will use the command, it will use the entry point from the container, and then we'll use your args from your configuration. And then the last case is if you supply both, and obviously if you supply both command and args, then your when the container runs, it will use your command and your args and ignore everything out of the Docker image. So again, I think the word command being used in two different ways was really messing with me. So I have to keep on reminding myself that that's how Docker containers interact with Kubernetes container definitions. Okay, that was just kind of a complete side note. Now back to the sort of effort at hand. So the next pattern here is we talked about logging. We saw that our container, we had a single container in a pod, and it was logging just fine. Now the question that comes up, what happens if your application, whatever's in your Docker container cannot write to standard out and standard error? Maybe you have a container that defaults to writing to some, /var logs blah, right? And it just writes to a file, not to standard out. And maybe you want to get logging, out of this app or this container. So the strategy here is you can install what's called a sidecar. And let's look at the example here. And the words are somewhat descriptive of what it is. It's simple. Sidecar, templates. Okay, so here I have a pod, right? And here I have, but the trick here is you write a second container in your pod. So your first container, let's say, and it's basically this, so this pattern here is basically the same command, right? It's running this loop. And I wrote it out a little differently just for experimentation. This is just writing it out instead of an array that looks like an array with blocks or brackets, it's an array that looks like dashes. So it's easier to read. And then this right here is a multi-line YAML format here, right? So the difference here is that before I was echoing it to the screen, and now I'm echoing the output to a file called var log applog. So if I run this top container, and if I was looking at the logs of it, there's nothing to see because the logs are basically, the output is basically written to a file, not to standard out, right? So the trick here is okay, as you may have guessed. You write, you actually create a volume, so you create an empty volume that your whole pod can share. You mount that volume on one container to var log, right? And then you write a separate container here called sidecar, and it mounts that same basically folder, right? So that they both now can look at the same log file, right? And then I just got this from somewhere else. There's a tail command, and this essentially says look at the tail. It basically will always read the last line. So it's always reading the last line continuously of this log file, and it's outputting it to the screen to standard out. And so if you think about it, that's essentially what what you might want out of your logger, right? You want this file basically being, as it's being written to, you want it being written to the standard out. And that's what this command does. So we just run this real quick to prove that it works, and then that's really all there is to this one. So if I do Helm, did I uninstall the other one? No. Helm. Oh, this takes a few minutes to terminate that container too. I'm going to pause the video for a minute while the container terminates, or the pod terminates. Okay, I'm back, and we got a clear cluster now. So Helm install give me a second. Install dev sidecar. Okay. Okay, so I got my pod running. So now the first thing you'll notice, if you just try to do this, you will not get, oh, that's not what I wanted. Oh, it's okay, it's logs. Sorry. So we'll get an error here because we actually have a pod that has two containers. So it's either you got to either choose a container of app or sidecar. So I think you say minus container. And we want to, if you look at app, you'll notice there's no output. But sidecar, if everything's working, should have the log. And I think you can also tail that log too, or you can watch the end of that log, and you can see it's behaving just like the previous example, right? So this is called, a pattern is called creating a sidecar container that can help with the logging. Okay, I think that's all I wanted to cover there. Helm uninstall dev. Okay. Oh, okay. So next thing, if you read the docs on Kubernetes, they make an argument that you need to make sure, since these logs are now being stored on your nodes, right, in your container engine, you want to make sure that your logs are being rotated on those nodes. Otherwise, it could get basically blow up the hard disk of your nodes. And so let's go look to see. Nothing in the documentation for we're using EKS, right, from Amazon. Nothing in their docs would suggest how they're rotating those logs, but you can look under the hood. So let's see if I can get onto one of my nodes. So I'm logging to my Bastion host first, right, and then from there I'm going to log into one of my nodes. I believe this is it right here. I did this earlier. Okay, so I'm sitting on my node, I'm a super user, and there is a configuration file called etc docker okay. So this is basically, I didn't write this. This came installed on my node, right? But you'll notice that it has a logging options. And I think the way this reads is that each log file could be no bigger than 10 megs. right? And there can be no more than 10 log files. So if I do my math right, that gives me 100 megs worth of logs that are kind of kept in memory. Now that just means is that, log data, without something else going on, log data will get like a long running pod. You can imagine this is across all the pods on this entire node, right? So that's a lot of log. I mean, there's a lot. You could have a lot of pods running and run out of logs. So we're going to have to figure out a way of keeping logs, getting logs out of the nodes, right? Because maybe we want to look at a log from a week ago or something, right? So this is where we kind of get into how we're going to log, data from Kubernetes out to some other system. Now, this is a quick sidebar. Whenever you see logging as it relates to Kubernetes and like retaining logs, this library called FluentD comes up, or software. And it's always seems to be used, it's always mentioned, but in the end, it seems to be always used under the hood. So what happens is different providers like Amazon will have a service for logging, and then they'll say under the hood we use FluentD. And so I kept on wondering what the thing was. And it's basically open source software. And this picture, I think, pretty well represents what it does, right? So what it is it's a piece of software that has the ability to parse and read various log format files, right? And files, or it's usually like a basically tail a file, right? And it can ingest it and put it into some sort of standard format, and they use JSON internally, right? So they'll kind of normalize all your log files into a common format, can then turn around and do some filtering on it and kind of get at what you want. And then it can then output it, thus the arrows out, in a variety of systems for storage. So it's kind of like a filtering, buffering, and routing engine to ingest logs and then output them into other systems. So that's all it does. It's kind of works behind the scenes, right, at a fairly low level. And we'll see it come to play with Amazon's solution. For, again, what we're trying to do is get logs out of Kubernetes, out of its like Docker engine logging that's limited, and put it into something more permanent. For example, we're going to put it into CloudWatch, which is Amazon's logging, one of the ways that they handle logging. Okay, so before we get to that though, let's talk about different patterns for getting log data out of our basically container, right? So one solution, although pretty hard, might be difficult because you have to implement it yourself, right? Let's say you have a logging backend. Say that's CloudWatch, right? You could just write your own code in your own container, right? So you write your container, and in that container, along with your code that you're running, you actually have code that grabs data and just pushes it into logging backend. And that would be a fairly expensive task because you're writing code for all that. Another solution, not terribly much better, but let's say you want to separate out this. You actually have your app container, right? Write to some log file like we did before, and then you write a sidecar app, a logging agent, that grabs that data and then sends it off to the logging backend. Again, that now requires the logging agent to be written with some custom code, or maybe off the shelf. But the idea here is still not ideal. One reason it's not ideal is that now you've got all these extra containers floating around. Every pod you have now has an extra container that's got more stuff going on. Okay, so the easier solution, or the easiest solution, and the solution that seems like all credible solutions have is they use what's called a node agent. So it's essentially a pod that runs on like in a daemon set on every node, right? And what they then do is they're all the pods. Okay, so let me Okay, so there's a node. That's what this right here is. The log agent runs, pod runs on the node, right? The pods themselves just write the standard error and standard out, just like we did earlier, right? So they're just doing the usual thing. The Docker container grabs the logs, keeps them around for a while. And then what you do is you have a logging agent that can actually interact with the Docker container itself and grab those logs, right? And then it then interacts with the logging backend, right? So this diagram here essentially represents the final outcome, of most solutions I've seen for permanently storing log data, and in particular with Amazon solution. There's a logging agent that runs on every node that gathers the log files from the container engine and sends it to CloudWatch. Okay, and so what they call theirs, Amazon, in fact, let me open it real quick. It's called Container Insights, and they have an install here. Well, basically, it essentially does what we just described. It's basically gathering all the data and storing it in the CloudWatch, which is their log. Well, it does more than logging, but it does logging, right? And there's a setting up section, and there's setup for EKS and Kubernetes, basically Kubernetes. And you can go through these instructions. There's a prerequisites. There's a quick start. It's basically one line. It's pretty easy. They also say you could also do it manually, which I started looking at. It was useful to look at, but it was fairly lengthy. I mean, it kind of went on forever. So I just decided to punt and just do the quick start, worked fine. So I'm not going to do that on screen. You can read that on your own. The link is in the notes for the script for the video. So did want to see after the fact, though, what it installed or what was relevant that was installed, right? So I'm going to show you, let's see, what is it? They created a new namespace called Amazon CloudWatch. Control, get, what is it, pods, Amazon CloudWatch. If I get this right, I'm on the wrong box, apparently. I'm still on my, okay. Now I need to do this. Okay. Copy, paste. Okay, so you can see that they do indeed have a number of pods, right? And in particular, I have 2 nodes right now. So I have these CloudWatch agents and the 2 of these FluentD CloudWatch. And so just so you know, we'll look at this in a future video. The CloudWatch agents are about collecting metrics, like CPU usage and stuff like that. So, and the second one, the FluentD CloudWatch, is basically the mechanism by which it collects log data. And of course, the clue there, of course, is it's also got FluentD in it. And this does indeed run as a daemon set. And see if I can daemon set. I bet you there should be at least one daemon set here. Right, so these, you can see that these indeed are running as daemon sets, right? So every node gets their own FluentD CloudWatch, which gathers those container logs that are in Docker, and then puts them in the, organizes them into pods, and then sends them over to CloudWatch. Because Docker itself doesn't really know about pods; it just knows about containers. So there has to be a little bit of work to convert them into assembling them into higher order objects like pods. Okay, well, either way, that's essentially how it works under the hood. And then I wanted to just show you what logs look like. Oh, I should be running I think I should have been running my example still. So Helm ls. Okay, so let me reinstall Helm. I'll just run the logger, the sidecar. They're both the same. Install dev sidecar. So I'm going to let this run for like just a minute or so to make sure the logs actually get into Amazon, and then we'll look at that. So I'm going to pause the video for a second. Okay, so I let it settle down for like a minute or so. So let me go to CloudWatch on Amazon Cloud, right? CloudWatch again is their logging and metrics system. They have metrics and stuff down here, but they have logs. So you go to log groups. Now there are three different log groups that we'll only worry about one of them in this video. But one is at the OS level, right? It's going to collect stuff about the nodes in something called host. And then data plane is basically going to be the services that are basically Kubernetes services that run on top of the host, right? And then the one that we care about right now is the container logging, and that's under application. So when you go to CloudWatch here, you want to look for /AWS, container insights, your cluster's name, and then application. And you can see there's the three right here, right? So if I go to application, I will see lots of different log streams. Basically, these are like all the basically the containers themselves, right? That have been running ever in my system, and there's a lot of them. I've been starting this thing a lot. So one here is, if you look careful here, the format is, for example, here's example dev, right? That's the name of the pod. Default is in this namespace, and sidecar is the container name. And then this must be some instance ID here, right? So this is what I'm looking for actually. You can see these are basically I'm running all sorts of different pods now in my system. Most of them are like system pods. But the one I'm really worried about right now is this example dev, right? And if you look at this log file, you will notice, hey, this is indeed, well, it's going to continually grow. Right, it just keeps on adding. But these log format looks like it's a JSON structure, right? And the log itself is the data. This is what we're actually logging. It came from standard out, right? Here's the container ID from Docker. And then it has some data around Kubernetes, right? This is the container name, namespace, pod name, other metadata around the pod itself. So essentially, that's how you can get at the logs. And these are permanently kept in CloudWatch. Now you pay for it, but these exist indefinitely. Even if you kill I'll have, if you look at this example here, if I go back under applications, you will notice I've been doing these examples before. So if you look below, you will notice earlier incarnations of, it's probably better. This tool has all sorts of way of filtering and stuff. Let's see if I can maybe filter on example dev, right? So now you can see I've been running all sorts of examples, right? And like earlier, I'm going to show my sidecars on this screen here. I've been like doing some stress testing on my newer videos. Anyway, there's there's a sidecar from earlier, right? So these are basically the logs from past. Okay, I believe that is the end of this video. So what was the focus of this video? The focus of this video was logging, but really only application logging, and how the logging gets temporarily stored on the nodes in the container engine, and then using some other tool. For example, in this case, we're using FluentD under the hood, but we're using an Amazon-specific solution to store it in CloudWatch. And the picture in your mind is this node agent pattern of having an agent run on every node that's collecting data out of the container engine and sending it to its back end. Okay, that's it.